Hi, good morning friends. In today's video, we are going to see how to find out the pipe thickness. As you see here, there are different parameters and formulas are used for that. But before going into the discussion, we must know few important points to understand this one quickly. For the piping design, like you see here, we have two important codes: ASME, American Society for Mechanical Engineer, ANSI, American National Standardization Institute. So these standards involve technical recommendation for designing piping system for various applications. Like you see here, ASME B 31.1 for power piping, 31.2 for fuel gas piping, and 31.3 for process piping. For example, we will see what is there in the 31.3. So in 31.3, the process piping, this section covers the minimum requirement for the design, material, fabrication, testing and inspection, operation and maintenance of piping application. And it has lots of products, like it covers the petroleum products and gas, oil and gas. You can use steam, air and chilled water also. It comes under ASME 31.3. The most common type of material used in chilled water system, oil and gas application is carbon steel pipes for both underground and above ground application. Three different type of carbon steel pipes used in above applications are ASTM A 53, ASTM A 106 and APA 5L. ASTM A 53 for black steel and galvanized steel, and it comes with welded and seamless arrangement. ASTM A 106 is standard specification for seamless carbon steel pipe for high temperature up to 750 Fahrenheit services. APA 5L mainly we are using for oil and gas, developed for line pipes used in conveying gas, oil and water in oil and gas industry. In HVAC or firefighting application, we mainly use these two type of pipe, ASTM A53 and ASTM A106. This API 5L pipe is mostly we can see in the oil and gas applications. The testing arrangement for the A53 pipes are less stringent or not tight compared with the A106. That is the reason A53 pipes are cheaper compared with the A106 pipes. So ASTM A53 pipes have three different grades and types. Like you see here, type F, that is furnace butt welded; type E, electric resistant welded or ERW; type S is a seamless. And these are the three types, and it has two type of grades, grade A and B. So for the mechanical property, if you see the mechanical property, type A and B, I mean the tensile strength and yield strength, each grade has different tensile strength and different yield strength. So type B, grade B has higher yield strength and tensile strength compared with the type A, grade A. Similar to ASTM A53, ASTM A106 pipes also have different grades, and its specification covers seamless carbon steel pipes for high temperature from the size of 1/8 inch to 48 inches. Pipes are defined based on nominal pipe sizes, and thickness is classified as schedule. For example, for the carbon steel, the schedule you can see it is 5, 10, 20, 30, 40, 60, 80 till 160. And for the stainless steel, the same arrangement, it will come with the S, 5 years, 10 years, 20 years, 30 years, like that. If the schedule values are increasing, mean the thickness of the pipes are increasing. So pipe dimension can be found in two standard: ASME B 31.10, that is for the carbon steel; ASME B 31.19, that is for the stainless steel. So this is the arrangement. You can see we have the nominal pipe size to identify the pipe. We have the outer dia, we have inner dia, and pipe wall thickness. For example, if you consider the 2-inch pipelines, the 2 inch is the nominal pipe size. You are saying 2 inch means it's a nominal pipe size. And for the 2-inch pipeline, the outer dia and inner dia will not be 2 inch. Okay, so the 2 inch what we are saying is the nominal pipe size for the identification only. So we will see what is that. The NPS is very closely related to the inside diameter. Okay, it's very closely related, but it's not exactly inside diameter, but only for NPS, nominal pipe size, 1/2 inch to 12 inch. This is the arrangement. When we go to more than 14 inch and larger, this NPS is equal to outer diameter. Okay, so till 12 inches, NPS is not equal to inner dia, not equal to outer dia, but it is closely related to inner dia. But when the sizes goes 14 inch and higher, that time the NPS is equal to outer dia. You can see one example, so it will be clear for you. In the left image, you can see the 6-inch schedule 80 pipe I have shown here. So here the 6-inch pipe is the nominal pipe size. For the 6-inch pipe, you can see here the outer dia, it is 6.625 inch. Okay, and the inner dia is 5.761 inch, and the 6-inch pipe is only the nominal dia. Both the outer dia and both the inner dia is not matching the 6-inch. But when it comes to 14-inch schedule 60 pipe, you can see the inner dia it is 12.5 inch, the outer dia it is 14 inch. So the outer dia will match with the nominal pipe size for the 14 inch and above. So this is ASME B 36.10, which is used for the carbon steel. You can see here the different nominal pipe size is given. For example, 3 inches, schedule 10, 30, 40, 80, 160. So you can find different schedule number here. And the related outer dia is a constant value for the outer dia. Only the inner dia will be keep on changing based on the pipe wall thickness. For example, schedule 10 here, the wall thickness is 3.05. For the schedule 30, it is 4.78. Schedule 40, it is 5.49. Okay. So based on this table, we will find out the pipe dimensions. So today we are going to find out the pipe thickness calculation based on 31.3 ASME B 31.3, which normally has the transportation and storage of all fluids. As I mentioned, it covers the chilled water, it covers the oil and gas, steam and air, everything. So let's start the calculation. The required thickness for the straight section of pipe shall be determined using the formula Tm is equal to T plus C. In this one, the T is equal to we need to refer some additional parameter like internal descent pressure, outside pipe diameter, allowable stress, and the weld joint quality factor, weld joint strength reduction factor, and coefficient. So these are the 4 parameter you can simply take. We can simply take from this ASME B 31.3 and we can apply in the formula. So these 2 formula you can refer from class 304.1.1 of the ASME B 31.3. I will show you that. And additionally, for Tm is equal to T plus C and C, there is one more important thing. We have to have the corrosion allowance. So C1 is the corrosion allowance, that's equal to sum of mechanical allowance plus erosion and corrosion allowance. So in the piping system, there are lots of corrosion we have. So I will show you what is that. So like you see here, there are different type of corrosion involved in the piping. General or uniform corrosion, that is like a uniform metal loss will be there. So pitting corrosion is there, galvanic corrosion, concentration, and many more. So these are the things, that's the reason we are adding some amount of corrosion to the pipe thickness. So that is C1. And coming to C2, when you have small size pipes like less than 2 inches, we will do the threading to connect the one pipe to another, and more than 2 inches we are normally doing the welding of the pipeline. So when you do the threading, there is a chance that some metals are loosened from the pipe material, so that will reduce the strength of the pipe. So that is the reason again we are adding some allowance because of the pipe threading if your pipe size is lower than 2 inches. So in the threading general, there are 2 type of arrangement we have. One is the BSPT and NPT. NPT is a national pipe thread and BS for the British standard pipe thread. So like you see here, ASME B 1.20.1, this is the NPT is related to American standard. So using this standard, we can find out the thread sizes and thread inches. For example, I have taken this table. What you see here is a nominal pipe size. I just consider 2-inch pipe size, nominal pipe size. In the 2-inch pipe, for example, you can see threads per inch. That means if you have one 2-inch pipe, there will be around 11 thread will be there in 1 inches. Okay, this is in inches, thread per inches. So 11.5 thread will be there in 1 inches. And coming to this table, table 1, thread per inch is 11.5. That means it has the it has the depth of 1.91 mm. Mean that much depth is there. Like you see here, this one, there will be 1.91 mm depth will be there for that thread. So we need to add this 1.91 mm the allowance when you have the pipe size lower than 2 inch. So in this example for the thickness calculation, I have considered the below value. The pipe material I have considered ASTM A 106 grade B, and the pipe type, so ASTM 10 grade B, we have the normally seamless pipe. So descent pressure for this system 31 bar or 0.45 KSI I have considered. KSI means kilopounds per square inch, and descent temperature for the system I considered 350 degree Fahrenheit. And the corrosion allowance, as I told you, we have to add some corrosion allowance because of the pitting corrosion and many more things. So 3 mm for the carbon steel is normally considered, and 0 mm for the stainless steel. Stainless steel, there is no corrosion allowance considered. So this corrosion allowance should be based on the required service life, acid concentration, temperature, geographic location, and upon whether the internal protection coating is installed or not. But generally 3 mm is considered for the carbon steel. And the mill tolerance also we need to consider later. So mill tolerance means, for example, when you receive the pipe in the site, normally the quality engineer will measure the pipe thickness and the pipe outer dia, inner dia. So that time what will happen, if the pipe thickness is for example 4.2 inch inner dia I need, means I cannot get exactly 4.2 inch, because of the manufacturing time there will be some allowance are acceptable as per ASME B 31.3. so sometimes the pipe inner dia will be slightly higher or slightly lower than that one. If the pipe size is, if the pipe thickness is slightly higher, then we don't have the issue, but if it is lower than that one, mean it is acceptable by the standard. But when it comes to thickness calculation, we have to consider that acceptable lower value also. So normally 10.5% plus or minus is acceptable. So we will see how to do this one also. And pipe size, we are consider 4 inch. For the 4 inch pipe size, the outer dia is 4.5 inch from ASME B 36.1. So let's start the calculation. So in this formula, first I need the pressure, internal design pressure, maximum internal design pressure. That one already I consider for this example of the system. And the D is the outer dia. For the 4 inch pipe, the outer dia is 4.5 inch. That we already consider. The next one is the S. S is the allowable stress. And let's see how to find out this one. So you have to go to ASME B 31.3. This table. The table is called as a table A-1. Basic allowable stress for the different material. Like you see here, the different material allowable stress is given. So for us, it is ASTM A 106, and the maximum temperature, design temperature for our system is 350 degree Fahrenheit. So you can see the X direction, there are different temperature is given. So it starts from the 400 degree Fahrenheit, the unit is degree Fahrenheit. So our case it is 350 degree Fahrenheit, so we are before this one, so we can take this value before this one. So the arrangement is like 19.9 we can take till it is 400 degree Fahrenheit. If it is 500 degree Fahrenheit, then we can take the next value. So you can see here, when the temperatures are increases here from 400 to continuously, the allowable stress values are decreasing. Okay, that is the concept here. So in our case, we are going to consider 19.9. The unit is in KSI for the allowable stress. So here the allowable stress is calculated. The next one what we need is the weld joint quality factor. So the same ASME B 31.3 we can find out this one also. So here you can see ASME B 31.3 basic quality factor from table A-1B, and here normally the quality factor is 1 for the seamless joint, because there is no welding joint in the seamless one, so it's equal to 1 for seamless one, and 0.85 for the electric resistant welded pipes, ERW pipes. Is 0.95 for the electric fusion welded pipes, and 0.6 for the butt welded pipe. So like you see here, different materials are given here. So for our case, it is A106, ASTM A106 pipeline, and it is a seamless pipe. So the E or the quality factor is 1. So we need to consider this one. So here the answer of S and E is already found. Now we need to see what is weld joint strength reduction factor. So when a component contains weld, the strength of the component can be influenced by the creep in the welds at a higher temperature. That means the creep means there is a chance that the permanent deformation will occur when a material is exposed to high temperature and constant or varying stresses. So in the piping system, normally what happens, there will be the piping system will normally undergo different stress, different temperatures, higher, lower temperature, due to if it is exposed to sun, then will be different temperature. If it is buried, then will be different temperature will be there, and also it will undergo different stresses. So due to this, there is a chance that the weld will go for the permanent deformation. That means the creeping will occur. So the creeping will reduce the strength of the weld. So that is the reason, as per ASME course, ASME B 31.1 and ASME B 31.3, this reduction in strength is incorporated in the calculation. So it's called as a weld joint strength reduction factor. In ASME B 31.3, table 302.3.5, it has given the value of weld joint strength reduction factor. So you can find in this table, for example, you can see austenitic stainless steel. So stainless steel is also given and carbon steel also given. For the carbon steel, normally we are considering CRMO, that is chromium and molybdenum. So most of the things falls under this one, chromium molybdenum category group. So you can see the temperature. For in our case, it is less than 427 degree. So we need to consider this value as 1 for the weld joint strength reduction factor. So here also, when the temperature is going high, you can see the weld joint strength will go low. Okay, so this is the important thing here. So finally here we have one more last value, that is coefficient. Let's see how to find out this one. So as per table 304.1.1, we are going to find out the coefficient, but you have here two conditions. The first condition is thickness less than or dia by 6. Okay, if you have this condition, you have to follow this table. For example, if your thickness is if your dia is 100 mm, so 100 divided by 6, so your thickness must be less than 16.66 mm. Okay, actually what happened, most of the time 99% this will be satisfying this condition. That is the reason we are referring this table. Suppose in your case the thickness is very high, we are not satisfying this condition, mean you have to apply this special formula. Okay, so now here you can see they have given the material group for the carbon ferritic steel, austenitic stainless steel, like that. So ferritic carbon steel falls under this one. So we can see the condition here. The temperature given in 90 degree Fahrenheit or 480 degree and low. So in our case it is lower than this value. So we can follow 0.4. So here finally you can see maximum descent pressure of the system 0.45 KSI we have considered. Outer dia is a 4-inch pipe. So 4-inch outer dia from ASME B 36.1. I consider 104.3 mm. I showed you that. Allowable stress and weld joint quality factor, weld joint strength factor and coefficient, all this value we have taken from ASME B 31.3 with a different table reference like I showed you. Finally, if you apply all this value, the thickness we record is 1.27 mm. Okay, so here as I told you, we need to add the corrosion allowance also. So corrosion allowance we have to consider 2 points. If it is the carbon steel, the mechanical corrosion allowance, first of the mechanical corrosion allowance. If it is the carbon steel, then we have to add the 3 mm. That is what I added here. 1.27 plus 3 mm, 4.27 mm. And second important thing is the depth, the corrosion allowance for the threading. In our case, the pipe size is 4 inch, so I don't need to go for the threading. It will be a welded joint. If the pipe size is less than 2 inch, then I need to go for the threading. That time you have to add the thread, the depth also, like I showed you. And so finally, we need the thickness for this application is 4.27 mm. So let's see what is the required schedule for this one. So here it is ASME B 36.1. The schedule number is given, different dia, different nominal sizes. Schedule number is given, outer dia and wall thickness is given. So you can see here down. Okay, like you see here, for the 4-inch pipeline, schedule 5, 10, 30, 40 is given. So in our case, we need the thickness of 4.27 mm. So 4.27 mm, it is falls between these two. So the next nearest available schedule is schedule number 30. We can see 4.78. Okay, we have 4.27 mm. The next available schedule is schedule 30 only. So that will be 4.78 mm thickness. So here I selected pipe schedule 30 and thickness as per the schedule is 4.78 mm. But there is one more important thing, as I told you, as per this code, there is a mill tolerance of 12.5% is acceptable in the manufacturing time. For example, if you have 100 mm dia pipe and the 100 mm dia pipe, for example, you need 10 mm thickness. So when you receive the pipe at site, you can measure the thickness is like 8.8 mm. So there is a reduction of 1.2 mm. So you need to check the tolerance limit is less within the limit of 12.5, whether it can be plus 12.5 or minus 12.5. So it is less than minus 12.5 within the limit bin, that reduction in thickness also acceptable. But coming to the design, that tolerance of 12.5 also we need to verify to find out the thickness. So let's see how to do this one. So here for the 4.27 mm is my required thickness. From the table I selected the nearby schedule, that is 4.78 mm. So I need to reduce 12.5% that tolerance limit. Here you can see I have removed this 12.5% tolerance limit. So I get the answer of 4.1825. I removed the value from 4.78. So I get the answer of 4.1825 mm. So if you see here, I need 4.27 mm, but I got 4.1825 after the exclusion of 12.5. So there is a difference of 0.09 mm, that is in the minus value. So this selection is not acceptable. We need to go with the next high thickness. So here you can see we initially selected schedule 30, that is 4.78 mm. So the next available schedule is schedule 40 and here the thickness is 6.02 mm. Let's see whether it works or not. So here I am going to change now schedule 30 to 40 and the thickness as per the schedule is 6.02 mm. You can see here it is 6.02 mm for the schedule 40 and thickness without mill tolerance, the 12.5%. After removing that I am getting 5.2675. So I need is 4.27. I am getting 5.26. I have the limit of difference of 0.99 mm in positive. So this thickness selection is acceptable now. So in this way you can find out the pipe thickness for the different applications like HVAC, chilled water system, oil and gas, etc. So thank you for watching the video. We will see you again with another interesting topic. Till then, bye bye.